Leon, you are muted, just in case here.
Can you hear me now?
Yes.
All right, thank you. Thank you for the nice introduction, and thanks for the opportunity. Today I'm talking about PubChemRDF. It is more about application of ontology. It seems I hear some echo. Hope you hear my sound clearly. Okay, PubChemRDF. PubChem is open repository for chemistry at the U.S. National Institute of Health. PubChem contains chemical structures like activities of chemicals and their gene protein targets, biological pathways, literature, pattern, health, safety, toxicity data, and more. So the data, everything in PubChem is free to the public. PubChem organized the data in 3 interconnected databases: compound, substance, and BioAssay. Substance database has original sample data provided by PubChem depositors. BioAssay database contains biological experiment results of substances in substance database. Compound database aggregates information from the other 2 databases and provide a comprehensive annotation about a chemical. So as of September this year, PubChem has over 100 million unique chemical structures, more than 207 million activities, 31 million literature, 24 million of patents. They are contributed by over 700 independent organizations, including chemical vendors, journal publishers, research development institutions, government agencies. So all the data is still increasing on a daily basis. So PubChemRDF is a semantic version of a PubChem. It is integrating heterogeneous data. So here is an example of a chemical drug, atorvastatin, or its a Lipitor for its brand name. So there are multiple substances with a different substance ID provided by several PubChem depositors, including ChemB, Campbell, ChemSpider, Protein Data Bank, PDB, as shown green in the graph. So this substance is in fact the same chemical, so are normalized into one single compound structure with the compound ID, CID 60823. So the relationship, the semantic relationship is represented, demonstrated in the graph. So from this normalization, more annotations about this chemical can be added. For example, it has a drug name, atorvastatin. It has an international chemical identifier, HT, and it is discussed in publications with the PubMed ID, PMID. And it is also associated with the anatomic therapeutic code, ATC code. So what's more, PubChemRDF also represents many attributes of this drug. For example, it has a molecular weight of 558, and its related compound structure. For example, it's sterile isomers, it's isotopic isomers, and it's a salt structure or Tiejun structure, you want to say, and it's 2-dimensional or 3-dimensional similar compounds. All this association can be represented in the RDF graph. In fact, PubChemRDF not only provides chemical semantic information, but also provides its related gene protein targets, protein domains, bioassay experiments, biological pathways, and more important, their regional provenance. This data is organized into 16 subgraphs or subdomains that's highlighted in the graph in yellow. PubChemRDF is also linked to external resources, such as Wikidata RDF, Uniprot RDF, PDB RDF, Mesh RDF, are highlighted in blue. PubChemRDF use existing standard ontologies from the community to create semantic relations. So rather than create a set of our own terminologies, here is a list of standardized ontologies we're using. So there's you guys may be more familiar with this. So this is a subdomains of PubChemRDF. So these domains can be loaded together or separated into a Sparkle query or local triple store. As of now, PubChemRDF has about 80 billion triples in total. So it is a relatively large RDF graph. This is also the reason that we divided the data into subdomains. So the question is how to access PubChemRDF. There are two ways to access PubChemRDF. One is through the RESTful interface. The other is through active site. So RESTful interface allows to link PubChem data through other RDF or semantic aware resources. Active site allows bulk download to local chip stores for the analysis. So here's the RESTful interface. It contains endpoint URL and parameters. So there are two types of parameters supported. One is required parameter, the other optional. For the required parameters, so a query is required to specify a graph or a domain and the name or string to search. For the optional parameters, it supports a more sophisticated query, such as a subject, object, predicates, and maybe substring search, format, limit, offset, etc. We can, yeah, this is more about examples how to use PubChemRDF REST interface. For example, if you want to search atorvastatin against the synonym subgraph, we should construct the URL this way. We specify the graph synonym and the name atorvastatin. If you want to search the first 10,000 synonyms that are drug brand names, so we specify the graph synonym and also provide the predicate RDF type, an object of a brand name. So if we want to search 10,000 synonyms that are either Chemical Abstract Service CAS number or European Commission EC numbers with an offset of 1,275,000. So we need to specify the parameters this way: predicate RDF type, objects with either CAS number or EC number. Please notice that you can support multiple parameters separated by comma and the offset. So PubChem RESTful interface supports multiple types for data retrieval, such as Turtle, N-triple, XML, JSON, LDJSON, etc. And the PubChemRDF active site also organized in a similar way into subdomains for bulk download. Recently, PubChemRDF is working on integrating more data, such as clinical trial data, disease data, pattern data, and add more data of literature, and update some of the data of gene protein data and pathway data. So the last, I want to acknowledge the PubChem team. Dr. Evan Bolton is the project lead. Gongfu is a former PubChem member who is one of the regional developers of this resource. I would also like to acknowledge the PubChem users, depositors, and collaborators. Of course, the funding support. Thanks. I guess I'm ready for taking any questions about RDF.
Okay, thank you very much, Dr. Leon Lee. Is there anyone who has questions for Dr. Lee about PubChemRDF?
Yeah, I have a question. Yeah, Leon, it's a very good talk. Yeah, one question I have is about does PubChem or PubChemRDF have some resources to support COVID-19 research, like drug, vaccine, and some other resources? Yeah.
Oh, thanks for the question. It's a very good question, actually. We have the sources for supporting the COVID-19, but those data is in PubChem database or homepage, but we haven't yet integrated them into RDF format.
Okay. Yeah. Thank you.
Hey, Leon, this is a question actually from the ICBO 2020 meeting when I introduced the clinical trial ontology. So people are asking, what is your PubChemRDF's relationship with CABI? So I saw that you are using CABI as a class level, right? And then you have a substance also linked to CABI. Can you explain a little bit more there?
Oh, yeah. So CABI is an important ontology for chemistry. Actually, CABI is one of our depositors as well. So that's we have the substance data of CABI in PubChem. So we use that data linked to CABI.
What do you mean by substance data in CABI?
I mean, remember, PubChem have the 3 interconnected databases. Substance data database contains original data from PubChem depositor. CABI is one of the PubChem depositors. So we use the data from CABI substance and link it to PubChem compound database and other like BioAssay through the structure normalization.
Do you mean the CABI is part of the PubChem?
Yes, you could see it this way.
Okay, thank you.
Thank you. If there's no further question, I think that this is going to be a great resource for the community. So, and thank you for introducing the PubChemRDF.